Hey everyone, please log into Clever. All right, so I want us to express some gratitude today. So, for your kind of icebreaker, describe something that you are thankful for today in this moment. All right, welcome to lesson 9 of week 5. We're focusing on water contamination and how it affects us. What is the effect of this on us as humans? My usual reminders, check your assignments for grades or comments or requests to change something. Also, make sure that you're watching your ed puzzles all the way through so those grades upload to Google Classroom. Remember to always use your resources on assignments, on quizzes. Realize that stuff builds on itself. So, like yesterday, I was helping a student with writing a reflection question, and I kind of guided them to go and look at their previous notes to help them out. Remember, you have those things, you've done the work. Take advantage of it and use it. Remember our expectations to be safe, responsible, respectful, and prepared and here as students. So this week we are talking about again water's impact on us and our impact on water. Specifically thinking about how contamination is an issue and topic that we should focus on. The assignments for this week changed a little bit, ever so slightly. We got rid of the number 21 check for understanding quiz because that was it was extra. We didn't need it. So we just have this contaminant failure model, which I will talk about at the end of this lesson. Remember, always, you guys are here right now. So that means that you're probably doing things in the order you're supposed to. But if you don't attend the live lesson, you are supposed to watch this lesson recording, especially because it's going to help you know how to do the assignments. So like I said, I'm going to show you how to do number 20 so you're not clueless on what's going on. Keep working on makeup work. I realize that this is a challenging time for all of us and we're getting through it the best that we can. My way to help you is just kind of letting you guys work at the pace that works for you. So we're going to keep chugging along, but you do you and just do your best to get caught up and do some work. You can do it. Thank you for being here. Thank you for putting in the effort. I am so appreciative. That's what I'm grateful for today is you. All right, so your warm up. Would you drink water from a river, stream, or puddle? Why or why not? So it's interesting to think about this question because ultimately what you do drink does come from a river or a stream. Doesn't usually come from a puddle. Those are they are safe to drink from when the water is treated, which is going to be our focus next week. But the idea is that most of us would not just drink raw with river water, but we do drink river water when it gets treated and then comes through our faucet. So as we talk about water, I just wanted to make sure I clarify and give you some important definitions. So pure water would be a water without any added substances. Now, the reality is that the water is going to have there's not really pure water. Even the cleanest water found up in natural streams in the middle of nowhere that humans have never touched, that water still has some dissolved minerals and things in it. But if we're talking about pure water, we really just want to say that, or we're saying it's without any added substances. Now, impurities are things that are added that make it not pure. A contaminant is specifically a polluting substance, so something that makes it impure but is polluting and is not good, and we don't want it there. Another word that you'll see or hear from me is the solute or solute. That means that's things that are being dissolved into the solvent. So a solute is a contaminant or an impurity. I know it's complicated, but it doesn't have to be. All right. So last lesson, we talked about sources of water contamination. And we talked about the fact that there's kind of 5 major categories. So there's contaminations that could come through agricultural means, so from farms. There are commercial contaminants. Those are contaminants that would come from businesses where you can receive or buy a good or a service. There are industrial contaminants, and those are ones that come from factories. And then there are residential contaminants, and those are ones that come from places that you live. Other stuff kind of fits into this other. And we then thought about and started predicting or hypothesizing what are some specific potentially harmful contaminants that would come from those different spaces, right? And we thought about, holy cow, there actually are a ton of things that could end up in our water that we don't want there, and that come from these different sources. So what does this actually look like in real life? Well, here's your example. These water bottles represent or show what real water from real faucets in Flint, Michigan looked like about 5 years ago. And the Flint water crisis is something that maybe you've heard of before. And if you haven't, hopefully I can give you some insight into that today. So there's a timeline of events that led to this like just awful crisis for people that lived in Flint, Michigan. And so the first thing we're going to do is watch this short video explaining how we got to that place.
Remember the lead crisis in Flint, Michigan? It's 2017, and many people are still living off of bottled water. To understand how this happened, we need to back up to the 20th century. Lead pipes are laid to bring water to people's homes. Eventually, water is sourced from Lake Huron. It's safe to drink because they add a chemical that helps form a protective scale on the interior of the pipes. The scale keeps the pipes from corroding dangerous chemicals like lead into the water. In 2011, Flint city managers see an opportunity to save money by building a new pipeline to Lake Huron. But building that pipeline will take years. So in the meantime, Flint switches its water source to the Flint River. But they don't add corrosion control to the water, which would keep that protective scale intact on the inside of the pipes. It's not long before General Motors stops using Flint water because the water is corroding their parts. Residents notice problems too. The protective scale is flaking off. Corroding pipes turn the water brown and contaminate it with lead. Residents complain of rashes and hair loss, but the local government, state government, and the EPA all fail to take action. The crisis continues to unfold. And in August of 2015, concerned Flint residents, including Leanne Walters, a citizen scientist, partner with Mark Edwards, a researcher at Virginia Tech, to launch an investigation. Together with Mark's students, they collect samples from over 250 homes. After multiple scientific studies, the lead crisis is no longer deniable, and the city decides to switch back to water from Lake Huron. But damage to the pipes and to the people of Flint has already been done, and the population's faith in the government is lost. In December of 2015, a state of emergency is declared. 1 month later, the National Guard is deployed to provide bottled water to the residents. Aid has totaled to over $300 million. Now, new pipes are being laid across Flint. Authorities predict the project will end by 2020, but Flint may never be the same.
All right, so that is there's further PBS and Nova. You can watch more about this, and actually at the end of the presentation, I'll give you some links to some other places where you could go and learn more. So let's start with this. Based on what you just heard, are true or false? Things are purposely added to our water to keep it safe. So, true. In that explanation, he explained how when changing to the Flint River in Flint, Michigan, instead of the Lake Huron water, there was a chemical imbalance, or there was excess amounts of what are called chloroforms, or organic matter, and E. coli. And so that's something that can commonly be found in water, and usually some sort of disinfectant like ferric chloride is used to treat that, to kill and disinfect that organic matter. That's totally normal, and that actually happens in the water that you drink. But what happened here is that it was they had to use too much because of the amounts of organic matter that was in there. And so they had an imbalance resulting in highly acidic and corrosive water. So initially, even residents said that their water kind of smelled and tasted like chlorine. And that's because of this excess amount of ferric chloride that was added. That corrosive and acidic water then started to eat at the lead pipes. So the lead, first of all, most houses, even in Louisville today, do have some lead pipes somewhere, but it's not an issue or not something for us to necessarily be concerned about because there is this protective layer that is on the pipes to keep it safe for us. But when this water got corrosive and got acidic, that protective layer got eaten away. And so eventually what was left was the bare lead pipes, and that corrosive and acidic water, just like it was able to remove the protective layer, is able to then leach that lead into the water. All right. And so this overtreated water, this imbalance with the chlorine, led to this water being acidic and corrosive, such that it could eat up those lead pipes. And so there ended up being lead in the drinking water. Now, contaminants may be in your water, but if they are below EPA levels, the water is safe to use. Is this true or false? So this is actually true. The EPA is the Environmental Protection Agency. It is a organization that their job is to kind of protect us from government and organizations and companies from using the environment and creating health issues for us. So there are levels, so what are called maximum contaminant levels of all kinds of different contaminants. And as long as the water samples or water does not have above that level, it's not considered toxic or unsafe. But what happened in Flint is that the levels of lead reached toxic levels. So water in Detroit, which is just down the road from Flint, has an average of about 2.3 parts per billion. 5 parts per billion is above that is when you start to have concern. So when water houses in Flint started testing at 27 parts per billion and up to even as high as 158 parts per billion, that is incredibly concerning. That is a lot of lead in water. There was even in the Virginia Tech study that they did even collect samples that were up to 13,000 parts per billion, and 5,000 parts per billion is what would be considered toxic waste. That's absolutely crazy that people were experiencing this level of lead in their water just coming from their taps at home. So, in summary, there were several factors, but mainly the poor water chemistry that led to the dissolution of the protective pipe layer, which then allowed for the corrosive water to start eating into the lead piping. And so, lead ended up in people's water. And lead, this is a problem. It's particularly toxic for kids, but it can be damaging and make all kinds of people sick. But with kids, it can cause brain development issues as well as reasoning issues that are long term and are going to affect those kids for the rest of their lives. And so that's awful that people had to deal with worrying about unsafe and unusable water in their homes. All right. If you want to learn more about this situation, we just briefly have talked about it. There are all kinds of places that you can learn more. I like the Science of Flint's water because it really is talking about the chemistry of the water. The Vox explanation goes into the fact that there was a lot of political and government misgivings and wrongdoings here. There was a lot of hiding what the problems were. There was kind of sweeping it under the rug, taking advantage of the people and not fixing it. And it was so there's other explanations that talk about that side of this situation. As well as multiple full documentaries. The one that was mentioned in that video, as well as a PBS one that is, if you literally go PBS Flint documentary on YouTube, it pulls up there and it's an interesting watch. So, why is understanding water contamination important? It's important because we're the consumers. We're the ones that are using the water. We're the ones that are relying and trusting that it's safe for us. So we do need to have some sort of understanding so we can make good, safe choices for ourselves and our families. So, the assignment that I'm going to briefly talk about is going to give you an opportunity to explore lead or another contaminant a little bit deeper to understand what that is, how it gets there, how it gets out, and why it's a contaminant of importance for us to think about. So, number 20 is the assignment. It should have been posted for you under week 5 assignments. There is an Edpuzzle that kind of walks you through how to do it if you need some additional support, but I'm going to show you it right now. So you'll open up that assignment and it will take you over here. And so what you'll see is on the first slide, it kind of just gives you some instructions. You'll define what a contaminant is. And then the instructions purely state you're going to choose a contaminant, one of these listed here. When you choose it, you're going to click on it and it'll give you access to a link. You're going to click on that link and it will take you to a fact sheet about that particular contaminant. So the information that you're going to be collecting from that fact sheet, you're going to write the name of the contaminant that you choose right here in the middle. And then this is the information that you're looking for. You're going to fill each of these boxes. So the first is you're going to tell me what is this contaminant, and where is it commonly found, or what is it commonly used for. You're then going to tell me, how does this contaminant find its way into our water? What is the process that sometimes results in it ending up in our water? Why is it harmful, or what are the health effects when that contaminant ends up in our water or we consume it? And then lastly, how the heck do we get it out of our water so it doesn't become an issue? So all of this is listed in this document. Most of it will be listed at this top right here, but it is sometimes beneficial to read down here. So it talks about what is copper. Copper is a metallic element that is essential to human life. Too little is unhealthy, and too much can lead to copper poisoning. The body cannot synthesize copper, so the human diet must supply it through absorption. So that's why some people take copper or consume copper. Copper is good because it has produces enzymes that act as catalysts to help with your body functions, and it's good in different things. But when you have too much copper, you can have different things or different health effects that can even lead to liver, kidney poisoning, and anemia, which is really, really bad. So again, the health effects, it talks again more about what is happening, where it usually gets into is where it usually gets into our systems are through improper wiring and plumbing, excuse me, and talks about industrial discharge, copper salts, or corrosion. And then it talks about the treatment is how you can get it out. And again, that's down here, both in your house. These are things you can do or purchase, or when it says municipal, that's talking about what a city does to do that. So what does like the city of Louisville Water Company do to make sure that this gets out of our water? Actually, Louisville Water Company truck just drove by my house. Very good. All right, so you'll collect that information here and just learn a little bit more and a little deeper dive about a specific water contaminant. All right, what questions do we have about that assignment? Okay, all right, so tell me how you're feeling now after this lesson. I hope I didn't freak you out. And if you don't have any questions, you can get off and enjoy the rest of your day. Have a good one, and I will see you next time in class.